Welcome to Java EE6 webinar series from JPassion.com. Today's topic is Servlet 3.0 Advanced. So we have covered basic features of Servlet 3.0 in the beginning of this course, the topic number 2 right here. And we are going to cover some advanced features of Servlet 3.0, especially asynchronous Servlet and some security. By the way, the next webinar is going to be in January. It's going to be January 9th. So we will have a few weeks break. Okay, so let's start with the presentation. So here, the two major topics that we are going to cover. Servlet 3.0 async support, and then security enhancements. And then if you have time, we'll cover some miscellaneous features. So let's talk about Servlet 3.0 async support. Now, before we actually delve into Servlet 3.0 async support, let's talk about why this async support is important on this web application, the Servlet environment. So let's talk about some technical background a bit first. Now, one of the technical background we'd like to understand is the web server scalability and performance evolution phases. So, we'll talk about each of this, and as you can see, async servlet is in fact the last evolution phase for providing performance, high performance, and scalability. So, in the beginning, we have HTTP 1.0, and then we moved to HTTP 1.1. And then we have a concept of thread for connection and thread for request. And each of these has some issues, even though this one provides a better performance and scalability than this one. And this one provides a better request. Thread for request provides the better scalability and performance over a thread for connection. Each one still has some issues. So that's the reason we finally have what is called the async servlet. So let's talk about each of these in a bit more detail. So HTTP 1.0 has some issues. In HTTP 1.0, a connection between a client and server is closed after a single request and response cycle as a default. And of course, if you are sending multiple requests and if you're having multiple requests and response cycles with a server, that's inefficient. So in HTTP 1.1, connection is kept alive and is reused for multiple requests and responses as a default. So this is called the persistent connections. So this provides better performance, of course, because a client does not have to recreate TCP connection every time it has to send a request. So HTTP 1.1 certainly provides a better performance. Now, on the server side, we had what is called the thread for connection. So what it means is that it's used to enhance the scalability for web servers, and it's based on HTTP 1.1's persistent connections. What it means is that each persistent HTTP connection between the client and server is tied up with a single thread on the server side. And these threads are allocated from server managed thread pool. Now, once the connection is closed, then that dedicated thread is recycled back to the pool and is ready to serve other tasks. That sounds good. However, there is still some issues from scalability standpoint. So let's say you have X number of threads, and this X number of threads can handle only X number of connections. Now, for many websites, the user request pages, clients actually request pages from the server only sporadically, which means the connections are staying up between this request, and while this connection is being tied up, the server thread is also tied up. So this is a waste of thread resource on the server side, and this is causing scalability problem. By the way, a thread is actually pretty precious resource on the server side. Okay, so in this case, for X number of threads has to be tied up for X number of connections, even though each connection is not being used, all the time, because between the request there is actually idle time, and at that point, the thread is still being tied up with a connection because connection is still up. So next, so the solution to that problem is thread per request. So instead of actually tying up a thread per connection, now we want to tie up a thread per request so that we do not have to waste the thread resource between the requests, meaning when the connection is up there. So this is actually in fact supported in Java SE5's non-blocking I/O capability. So persist in this case by leveraging non-blocking I/O capability introduced in Java 4's I/O NIO package. A persistent HTTP connection doesn't require a thread all the time. Okay, so basically threads get allocated to connections only when requests are being processed. So when a connection is idle between the requests, the thread can be recycled. Okay. And then the connection is placed in the centralized NIO request select set to detect new requests. So whenever there is actually new requests coming in, that's the time the thread will be allocated from the pool. So this model is called the thread per request, and it potentially allows web servers to handle larger number of user connections with a fixed number of threads. So if you compare thread per request versus thread per connection, here you are dealing with X number of threads can handle only X number of connections, okay, from clients. Here, thread per request, you can handle a lot more connections with X number of threads because threads are not tied up with number of connections all the time. Okay, so it solves the problem, scalability problem of thread per connection that we just talked about in the previous slide. Okay. All right, so that's cool. In fact, the thread per request is being supported by most web servers. So, the Tomcat, Jetty, Glassfish, pretty much all the web servers out there, they are taking advantage of Java, the NIO to handle, to handle the request using thread per request model. So, you get this thread per request model implementation from the server, so you don't really have to worry about it as a developer, by the way. Now, that's cool. Now, there are other developments that actually impact the scalability and performance, AJAX. So AJAX enabled clients send more requests to the server because it sends a request whenever it needs to access the data from the server. So it basically increased the traffic between client and server. So it is a factor for new scalability problem. Now, this is actually a big one. Threads are accessing slow responding resources. So, so you got the new request, the server got the new request from the client. And if the request involves accessing remote resources, for example, web services or databases, and then that thread is being tied up to handle the access of those remote resources. So threads that handle these slow serving requests could be waiting for the responses coming from those remote resources. Okay, so for example, the thread is assigned for that request, and if that request involves accessing database, of course, accessing database is a very slow process, and until the database returns, the thread is tied up. Okay, so again, we have a situation, even though we are using thread per request model, as we talked about here, we still have a problem when the request involves accessing remote resources. Okay, which means in that case, the thread is again being tied up until the remote resources send back the response. So we need a better solution to this. So what we want to do is we want to recycle the threads that are waiting for a response from these remote resources, again by placing the request in a centralized queue waiting for available resources and release a thread. So basically, when the request involves accessing remote resources, which is very slow, we want to recycle that thread. Okay, so that's basically what Servlet async support is all about. Okay, so this basically shows Servlet 2.5 where thread is being blocked when it is accessing remote resources. This could be a database or this could be a web service. So, request is received from the client. A thread is assigned, and then thread is going to invoke remote resource, and during this time, until this remote resource is actually responding, thread is blocked. Same thing here. By using async support in Servlet 3, when it actually accesses the remote resource, at that point, you can release the thread. So the thread can be recycled. Now, when the remote resource is sending back the response, that's the time the new thread is being assigned from the thread pool to handle the response from the server. So this is what the async support in Servlet 3 is all about. All right, so basically idling thread impacts scalability. Okay, so as I mentioned before, thread is a very expensive resource on the server side, and you want to take advantage of, you want to actually leverage the usage of a thread as much as you can. So this is basically giving you an example why the idling thread impacts the scalability. So let's say you have a web application accessing remote web service handling 1,000 requests per second, and 50% of this request called remote web service, which is a very slow process. And then you have, and let's assume you have only 500 threads in container thread pool. So if this remote service is slow, it takes about 1,000 milliseconds, which is 1 second, then thread starvation happens in 1 second. Okay. At that point, the users will experience the very slow responses from the server, because the threads are basically, the threads are gone. There are not any thread that can handle those requests. Okay, so basically, this is if you actually see the evolution, if you see the evolution of the thread per connection, thread per request, and async servlet. Basically, all these ideas is to remove the idling time of the thread and to take advantage of the thread as to use the thread to its fullest extent. Okay. All right. So hopefully you got some sense of what the async support is all about. Now, when we say examples of remote resources, obviously web services or databases, those are the two primary examples of the remote resources that is taking a long time to actually to invoke and get a response. Another example is the event. Okay, so you could in fact have a chatting application, and your application is waiting for the next chat message from someone. That could be again another example of a very long remote resource. Okay, so basically at that point again, thread could be waiting for this chat message to be to be delivered from somewhere. Okay, so that could be another usage model, another example where this async servlet could be actually very useful. All right, so this is an example code, and so basically you are going to create what is called the async servlet object. So basically, by the way, you have to specify you have to specify the servlet supports the async by using async supported to equals true. Okay, so this is the way that you are indicating this servlet is async servlet. Okay, so when async support servlet async supported attribute is set to true, the response object is not committed on method exit. What it means is that when the servlet is declared as the async servlet, response object does not have to be sent back to the client. Okay. Now, so in this case, the way that you are going to implement async the servlet is basically from the request object, you are going to call start async method. And what you get back is what is called the async context object. You can think of this async context object, okay, is an object that contains this request and response. So later on, when response is supposed to be sent back to the client, this async context provides all the information. It has all the necessary pieces that response could be actually sent back to the client. Okay, so I want to actually read this one more time. Calling start async returns async context object that caches the request and response object pair. So this is what I meant. This async context object maintains the original request and response object. Okay. And this async context object is then stored in application scope queue somewhere. You could actually save it any place. Okay, it doesn't have to be in a queue. Okay, this is actually from the code of chatting application. So that's the reason that we have actually a queue for all these all these async context object from different clients. Okay. Later on, this async context object is retrieved by another thread to send back the response to the client. Okay. So here in this code, typically if it is not async supported servlet, then do get is going to send back the response, right? But if it is the async servlet, then there is no need to send back the response. Okay, so without any delay, do get method returns. So do get doesn't have to wait until remote resources to send back the response. Instead, it will just return. Okay, all right. We're gonna actually see some more examples in a few minutes. All right, so let's talk about, so one of the usage of the servlet async servlet is what is called server-side push or commit or reverse AJAX kind of things, okay? So let me actually talk about this server-side push or reverse AJAX or commit a bit, and then we'll see how async servlet can be in fact used to support this commit or reverse AJAX or the server-side push. Now, what is server-side push? Well, what is commit? The first generation AJAX is not asynchronous enough. So first generation AJAX is basically providing async support from the client to the server. Okay, so that client does not have to actually wait for the response from the server. Instead, client can actually continue the processing. Okay, however, it handles only one side, meaning it handles the one side asynchronicity from the client and server. The other part of the asynchronicity we want is that we want the server to be able to send back things to the client whenever it wants to. Okay, so full asynchronicity includes updates pushed from the server to the client at any time. So this is basically server-driven page update. Okay, so in first generation AJAX, when it actually handles only client side, the server still has to wait until the client polls the server. Okay, so we'll talk about that in a few minutes in a bit more detail. So it allows users to communicate and collaborate within the web application. And this server-side push is called sometimes commit or AJAX push or reverse AJAX. So this reverse AJAX or server-side push could be used in many different type of application. For example, like a distance learning. So whenever a teacher changes the slide, everyone actually see the slide right away. Okay, or collaborative authoring or auctions. So again, the collaborative authoring, whenever everybody actually change the document, you want everybody else actually see the change right away. Auctions like eBay, whenever someone outbids you, you want to actually get the that outbid information right away instead of you polling it, to find out there has been a new bid. Okay. All right, so I'm gonna actually move on to the next slide. So commit or AJAX push is basically providing it's a programming technique that enables web servers to send data to the client without having any need for the client to request for it. Meaning, the client doesn't have to poll it. Instead, the server should be able to send the data to the client whenever it actually has interesting event or data. Okay. So it provides a highly responsive and event-driven web application, like a chatting application or auction application or distance learning application, because it keeps the clients up to date with the data from the server. Okay. So advantage, of course, is a low latency, and it's not dependent on polling frequency. Okay, we'll talk about that in a bit more detail in the following slide. And the server and network do not have to deal with the frequent polling requests to check for the update. Now this, the one last item I'd like to actually mention is in HTML5, this is actually being supported natively through what is called the WebSockets, okay? Excuse me. All right, so this is basically the AJAX versus commit. So reverse AJAX. So the first, this is actually the original AJAX, one-side AJAX, and then these two, AJAX push or AJAX push, these two, second and third, they are server-side push. So in the one side Ajax, the browser has to poll the server to find out if there is anything interesting data from the server. Okay, so in the first time here, request request is sent from the browser to find out whether any interesting data, and the server says, "Oh, I don't have any interesting data," and then the server receives some interesting data as an event here, and this time from this event, the next time a browser polls, this is a latency. This is the time that client has to wait, okay, until it sends the next polling request. The client has to wait, okay. Now, in Ajax push or reverse Ajax, in fact, this long poll, the second model is the most popular reverse Ajax model. In this case, browser send the request to the server, okay? And until there is interesting data on the server side, the response is not going to be sent to the client, okay? So when there is actually interesting data on the server, then that's the time the server would send the response back to the client. Client received the data, and then it will send the request right away. So this request will not be responded until, again, interesting event happens, okay? The second scheme of this reverse Ajax is browser send the request, and the server send back the response whenever it received the interesting data. So it actually sends the response in multi-part fashion. Okay. Now this long poll is actually a lot more popular. The reason is because, let me actually move on to the next slide. So this first scheme is poll. Okay, so in this case, a poll is that send the request to the server every X seconds, and response is empty if there is no update. The long poll, so this is the most popular model. So client sends the request to the server waits for an event to happen, then sends the response. The response is never empty. Now, there is no client-side hack needed, okay? Because as far as the client is concerned, the server is just behaving as a slow server. Now, in HTTP string model, in this third model, the client needs to be changed. The reason this long poll scheme is a lot more popular is because the client does not have to change. Okay, the server just happens to be a slow server. In this case, this one, you need to change the client code. That's the reason this is not popular. Instead, this long poll reverse Ajax model is popular. All right, so that is actually basic, background information on what is called the reverse Ajax and the Ajax push, and we'll see how this servlet async is being support to support this server-side push or in reverse Ajax. All right, so before Servlet 3.0, meaning before async servlet is actually being supported, all the server implementation, they obviously want to take advantage of this, the scheme that I just mentioned. Okay, so what I mean is the feature that is supported by Servlet 3.0. So the server implementation, even though there is no serverless standard, all the servers actually have their own implementations that provide similar functionality like a servlet, async servlet. Okay, so Tomcat has a Comet processor, Jetty6 has a continuations, and Glassfish has what is called the Comet engine. Okay, so these are proprietary implementation of async servlet, if you will. Okay, so these are proprietary classes and interfaces. And of course, that's not, the applications are portable. Applications are not portable. That's the reason we need a standard-based support. So that's the async support in Servlet 3.0 is all about. So async servlet API in Servlet 3.0 now provides a standard and portable way of supporting server-side push. Okay. All right, so I'm going to actually show the sample application. Async. This is a chatting application. Okay, I'm going to actually take a look at the code in a few minutes, but I just want to actually show you the chatting application. Which is actually being used, which is actually using async servlet 3.0 to support this reverse Ajax. Okay, so this is a chatting application. I'm going to actually join. So I'm going to say Sang Shin login. So Sang Shin is joined, and then I can send a message. My first message, post a message, and I can send the second message. Okay, now I want to actually simulate another client. Okay, so I'm going to copy this URI, and I'm going to open another client. So I'm actually opening another browser, which is simulating another client. So this client could be actually located 3,000 miles away. Okay. So now I'm actually opening another client, and client can access this application. So, let's say this is the John. So John just joined. You can see the John is joined. That information is being actually propagated to the next, the first client. Okay. So whenever this John send a message, John's message to message one. Okay. You can see the Sang Shin is receiving it. Okay. Now if I send a message, okay, if I send a message to this chatting application, my message 567, then you can see this client, other client actually received that message right away. So which means on the server, whenever I posted a message to the server propagated the message to all the clients, okay, right away, okay, using this async servlet. Okay, so this is basically, the reverse AJAX or server-side push or commit I'm talking about. Okay. All right, so let's talk about the APIs. And I'm going to actually explain this code in a few minutes. Now, the way that you can specify that your servlet supports the async is that you can actually do using annotation. So you can use the async supported true with this web servlet annotation. That's the way that we, that's the example that we have seen. Okay. Or you can specify it in web.xml file like this. Or you can even programmatically set it. Okay. So you can call set async supported and you can say true. Okay. But this is probably the most common way of actually specifying your servlet is async servlet. Okay. Now there are actually several APIs. So you have seen this example: start async method of your request object, and it will return async context object. So again, as I said before, this async context object basically maintains HTTP request and response object. So whenever you need to send back the response to the client, then you are going to actually get the response from this async context object. Okay. You can find out whether the servlet supports async or not by calling is supported. Okay. Now there is actually dispatch and complete. So your thread that is actually performing some the task for example accessing remote resources. Once it is done, once I receive the response from remote resources, then you can call dispatch. So dispatch is basically dispatching to another the URI. Okay, so it dispatches the request and response object of this async context object to the given path scope to a given context. So it's basically passing, it's basically sending the URI to that. Okay, so and the complete is basically complete that async operation, and then it will actually return to the caller. There is also what is called the callback registration method. So add listener, meaning the you can actually receive some callback when something is done. Okay. So once you actually the add listener object, okay, to the async context object, then you can actually the receive callback. So this is the callback method: on timeout, on complete, and on error. Okay, so when timeout happened, the callback method will be invoked. When the things are completed, again, this callback method will be invoked. So we'll see an example of this in a few seconds. All right, so basically in async web service, as I said before, thread is actually being allocated to handle the request, and then when it actually trying to I'm sorry, this is your web application. So your web application, whenever it actually accesses the remote service, okay, so it's a database or web service and things like that, the thread is actually being deallocated. It's going back to the pool, okay, so that there is no idle thread here. And when there is actually something returned from the remote resource, okay, and then it will call the dispatch. Okay. All right, so let's see the code. So we'll see exercise 1 and exercise 2. Exercise 1 is basically exercising the APIs, and exercise 2 is the chatting application I actually demonstrated already. Okay. So we are going to try several applications, so async simple dispatch complete and listener completed and listener timeout. Okay, so let's run those applications. So let's try dispatch. Okay, so here we are going to run this application. Okay, so basically I call it, and then it will just send back the response. This page gets displayed after async servlet is called. Okay, so let me actually show the code. So when the application is started, this index.html file gets displayed. So when you click the click me button, it will invoke async servlet. So as you can see, this async servlet is annotated with async supported equals true. So this servlet is async enabled servlet. So the first thing we do is we created async context object. Okay. And then we are going to actually create the executor object. Okay, so this is Java SC5 concurrency class. So we create the executor object. Okay, and then we are going to pass a task. So what we want to do is the real task is being performed in this async runnable the object. So this is the object. Basically it's a new thread. So new thread will execute this task, and that task could actually access remote resources. Okay, and while this do get returns right away. Okay. All right, so you can just take a look at the Java doc. So this is the task that is being performed. Okay, so here basically we have async context object. Okay, and basically we are just simulating. We are just kind of sleep for 1 second just to simulate the long running task. So in this long running task, you might in fact access database or web service and things like that. And then you are going to call dispatch. So here you are going to respond. So this is time you are going to respond to the client. So in this case, basically you are going to send back the response to the client to response.jsp page. So this response.jsp page is basically displaying this message. Okay, so relatively straightforward code. All right, so that's dispatch. Now let's take a look at the complete. So complete works pretty much the same way. So let's run this application. You click this button and then async call is completed. Okay, so let's take a look at the code. So it works pretty much the same, exactly the same code, but here we are calling complete method. Okay, so in this case, it returns to the caller. The control is returned to the caller. So the control is returned to the caller. So this caller is going to construct at that point response message and response message and return. So this complete is is basically the same behavior as a synchronous servlet. Okay, because it actually performs a task and it wait until this is done, then it will return. However, the difference between the synchronous servlet and this code, even though the behavior is the same as far as the client is concerned, the thread is being released. Okay, so in this case, the thread is not being tied up, so it provides a better performance. Okay, all right. Okay, so now next one is the listener completed. So in this case, if I run this code, and click again, here, the thing we like to actually see is that there is actually some message. So on complete is called. Okay, so in this case, we are basically using a callback function. So here, in doGet method, you are going to create a callback. You actually assign a callback object. So here on the context object, you're going to call add listener, and then you're passing async listener objects. So when things are completed, okay, this callback method on complete will be invoked. That's the reason you're actually seeing this on complete. Okay. Okay, so this is the code. All right. The next one is, here this is a timeout. So in this case, the timeout callback method is also invoked. Okay, so we have call timeout. In fact, it will call both complete and timeout. So timeout is considered as a complete. So these two methods are, both of them will be invoked. Okay, so let's run that. Okay, click it. Okay, you can see both timeout and complete callback methods are invoked. All right. Now, next, this is a chatting application that I already demonstrated. So let me actually explain the code. Okay. So I'm going to use this hands-on lab documentation because it's, some code is highlighted. Okay, so this is a servlet. And, this is annotated with async supported equals true. So we know that the servlet is the async supported servlet. Okay. Now here we have two queues. One queue is the queue of async context objects. So this queue is representing the number of clients, okay, that sends the request. I mean, number of clients actually on this chatting application, okay. And then we have a message queue. This is a blocking queue. Okay. All right. So just remember the important queue is this. This is the queue, maintaining async context object, and each async context object in this queue represent a single client. Okay. Which means whenever whenever the client has to be responded, meaning whenever a response message has to be sent back to the client, this async context object will be used, from this queue. Okay. All right. So when this servlet is actually initialized, so this is init method. In this init method, we actually create this runnable task. So we create this runnable task, and this runnable task is basically take a message that has been posted, okay, and then it will go through all the async object from that async queue, and then it's actually sending back the response. Okay, so this runnable object will be used later on, and this runnable object, the task it does is that whenever it is asked, it will go through all the client which are represented by async context object, and then it will send the responses to those clients. So it's actually going through all the clients, okay, and then will respond to the client. Okay, all right. This is doGet method that gets invoked when a new chat client joins. So when the new client joins the chat, this doGet method gets invoked. Okay. So in this case, what happens is that it first of all created the async context object, and then it actually adds that context object to the queue that I mentioned. So every new client will be represented by this async context object in that queue. Okay. Now, in this async context object, we also have this callback method on complete, on timeout, and on error. Okay, what it means is that whenever something is complete for that particular client, we want to remove that client from the queue. So we are actually calling remove method from the queue, passing that async context object. So when a message is sent to the client, then there is no outstanding request from the client. So we want to remove that client from the queue, or a timeout, or an error. Okay. All right. So this is what happens when a new client joins. The key point is that the client is represented by async context object, and then async context object is put in the queue. Okay, so later on, when the new message is actually being posted, this runnable task will go through each of these async context object, which represent a client, each client, and then it will send back the response. Okay. All right, so this is the code. DoPost method is invoked when when either login occurs. So user will send the login request with the user's name, or a new message is posted. Okay, so depending on whether this is a login or is a posting a message, we are going to send a different message. Okay, we create a different message. Okay, however, and then we are going to actually call this notify method with that message. So this notify method is going to send that message to the queue. So we have the second queue that is maintaining the message, right? Okay, all right. And so basically, whenever someone posted a message, that message is going to be on this queue, okay? And then this runnable task will go through that message, okay? It will go through that message, and then it will just send back it will actually send that message to the client, all the client, okay? So a very simple code, okay? Okay, so the key point here is that the async servlet provides this highly efficient the asynchronous the behavior, so that the thread is not being tied up when the server is waiting for some resource. In this case, the resource is waiting for is the new message from any client. Okay, so that is async support. So let's move on to the next big topic, which is security enhancement. Okay. So security enhancement. So in Servlet 2.5, only declared roles and runners are supported in Servlet, but deny all, permit all, and role allows are only supported in EJBs. Okay. Now in Servlet 3.0, all these annotations are also supported in Servlet 3.0. Okay. So roles allowed, deny all, permit all, and transport protected. Okay. And this could be used at the class level or method level. Okay, so if you use it on the class level, then all method will be constrained by these security annotations. And another security enhancement in Servlet 3.0 is that you can actually call, that is in fact the login method and authenticate method and log out method on Servlet request. Okay, so by using login method, it actually replaced a form-based login. Okay, so form-based login has been around for a long time, and it is still being supported, of course. In form-based login, you have to create your own JSP pages for for displaying the login page to the client. Okay, which is a chore. Okay, so by using login, it actually simplifies it. Authenticate is basically the application initiated container mediated authentication. So you're basically the authenticating the user at that point. You can actually you can actually authenticate a user at a place that you want. Okay, and log out is again logging out. Another security enhancements is basically very minor. So here, you can use the web resource collection enhanced by the HTTP method omission. So let me show you what I mean by that. So in this case, in Servlet 2.5, if you want to constrain all methods like a put, so here, put, post, head, put, options, trade, and delete. All these methods are actually constrained by the security. So meaning, whenever clients send a request using this HTTP method, they will be constrained by the security. Okay, so this is a bit of chore, So instead of doing this, we can use like a get omission. So what it means is that except get, all the other methods are going to be constrained by the security. Okay, so these two are the same. It's a little bit of convenience. So the above two are equivalent. Both indicates that the resource referenced by URL pattern test.jsp page, when accessed by all HTTP method except get. So here, you don't specify get, but you specify everything else. Here you're going to use HTTP method omission, which means that except get, all the other things are actually constrained by the security. It should be constrained by the constraint to be viewed only by authenticated users belonging to role nice guys. Okay, here. All right, so let's do the hands-on lab. So the first task we have to do is, if you actually think about the security aspects of a web application or EJB application, there are two different security aspects. One is the security aspects of the server, in this case a Glassfish, and then you have a security aspects on your application. So obviously, the security roles that you define your application cannot be tied up with a particular app server because you want to actually run that application on any app server. However, you have to actually provide some mapping between those, the abstract roles, for example, on your application to the groups or users on the particular app server. Okay, so that is basically what we're going to talk about in a few minutes. So in this case, we're using Glassfish, and we are going to actually create user principles. You're going to actually create a few user principles. So you are going to invoke the admin console of Glassfish, and then you're going to actually select. Let me actually just show you. Admin console. So I have added already three user principles belonging to two different groups. Okay, so here server configuration. Then you are going to go to security realm, security, and realms. So the Glassfish support multiple security realms as a default, but it's using file as a default. So if you go file, you can actually manage the users. Okay, so I click manage users, and I have added three users. Okay, so this user, Sang Shin, belongs to Java EE6 users group. So these user ID and groups are actually Glassfish specific. It has nothing to do with an application. Okay, and then I have another user called the dude, who belongs to dude users group, and then we have a yeoman who belongs to the same group of Sang Shin. Okay, so basically the way that you are going to add a new users is basically if you click new, so here user ID, I can say Bill, and the group list, I can say, the Java E6 users, and the password is X, then you can add the user like this. So now we have, 4 users. Okay. All right. So once we created these users, on the server, on a particular server. So we are using Glassfish, and when you are actually running this app, and now we have to actually restart the Glassfish. But since I have already restarted with at least those 3 users that I've already created, I don't have to restart. Okay, but for you, when you actually add these users, you have to restart the Glassfish to have these users to be visible. Okay. All right, now we're going to actually run what is called the programmatic login application. So let's run this application. So here we are going to enter a few users. So here I'm going to actually enter Sang Shin, which belongs to Java E6 users, the group, and password is my password. Okay. And its login is successful. So the code basically displays before login, it check whether user is in a particular role or not is false, and everything is null because there is no user credentials. After login, this user is in role, and remote user principal is Sang Shin and Sang Shin. Okay, and authentication type is login, and after logout it should be all false as well. Okay, so let's take a look at the code. Now, if you try Yeoman and Yeoman, okay, it should actually work the same way. Okay. By the way, Yeoman and Yeoman actually also belongs to Java E6 users group. However, if I try Dude and Dude, who belongs to different users group. Okay, so if you take a look at the here, Dude belongs to Dude users group rather than Java E6 users group. Okay, so if I try Dude and Dude, okay, it's not in the what is called the nice guys user role. It's false. Okay, so let me show you what I mean by that in a few seconds. Okay. All right, so this is the code. So when you are running that application, this index.jsp page gets displayed. So it's going to, when you actually enter username and password, it will go to this URI, a login servlet. Okay. So if you take a look at the web.xml file, okay, so this is a web.xml file. We're actually providing servlet mapping. It's going to go to the login servlet, and that is actually represented by this login servlet. Okay. And here also you are using the the basic the authentication. Okay. And this is the code. So we have declare roles, nice guys. So this is the abstract role. This is application level role, meaning it has nothing to do with app server specific group or user principal. So we have to actually map these guys to some, in some place. Okay. So what it means is that this code will be accessible to anybody who belongs to these nice guys. Okay. And then we are just displaying, then we're actually calling login method with past username and password. Okay. So, this is the before logging in, and then we perform the login, and then we call. Now we actually check whether the user belongs to these nice guys or not. Okay. And I haven't still talked about how we actually map this abstract nice guys role to application specific principal or groups. Okay, so that's something I'm going to show you right now. Now this is the one, Sun web.xml file. So this is the app server specific file. So in a sense, this is the app server specific file. In this case, a glassfish specific file in which you can map your abstract role, in this case, nice guys, to your app server specific security realm group name. So basically, any role, anybody that belongs to this Java E6 users group, they also map to nice guys. Okay, so that's the reason when we check this is user enroll nice guys, it returns true. Okay. All right, so this is the the glassfish specific file in which you are going to map your application abstract role to the group or principal of the app server. So if you're using, for example, another app server, for example, Tomcat or the JBoss, then you have to map these things differently, in app server specific way. Okay, so Tomcat is a Tomcat users.xml file. And JBoss has to have its own file in which you have to map this nice guys abstract role to JBoss specific, user principal and group. Okay. All right. Authenticate. So let's try the next one, programmatic authenticate. Okay. So here, as soon as I actually run this application, it's asking me to, it's actually prompting this login screen because the method, the application is calling authenticate method. So as soon as authenticate method is invoked, the container actually pops up this login dialog. So here again, I can say Sang Shin and my password. Login, okay, and authenticate successful. Okay. Let's see, is login in feature? I have to check why this is the case. Yeah, I kind of change around. So this is authenticate. So basically, we call the authenticate method. Okay. So these nice guys should be, the reason it's not actually in the user role is that we have not declared, we have not declared roles here. Okay. Yeah, so that's the reason it's false. Okay. All right. That's that. And we, yes, show this code. And the next one is method omission. So let me just run this code. So here, whenever I try post, okay, it works. Okay. Whenever I try get, well, actually, I should actually restart it. So let me show the code first. So in web.xml file, basically what we have done is, oh, okay, so this is the, so what it means is that this, the nice guy's authentication will be applied, except get. Okay, so in this case, the get should work. Okay, but post should not work. Okay. Oh, it's actually the post. Uh, yeah. So this is in fact the same thing as this one. So the um, except get, So I'm gonna actually restart this browser. I have to actually. Okay, so it's all good. Okay. Let me just run this one more time, and I'll explain again. All right, so if I get, uh, okay, post, yeah, okay, so post. So here, if I provide my password, yeah, oh, Sang Shin. Okay, so in this case, both works. Okay, now if I change, and then I'm gonna actually close this guy. The reason you want to actually close and try this one again is because the browser will actually maintain your user credentials. Okay, so in its cache, so you have to actually to experiment with this one. Now I'm going to actually change this one to post. Okay, so now if I try this one, that works. Get. Yeah, I'm a bit confused. Okay, that works both. So I just want to actually. So what I want to try is. So if I say post, that means except post, everybody should be. Oh, okay, yeah, that's the thing. So in this case, the except post, everybody is actually constrained by this security. So that's the reason we actually call the get. Okay, it's actually popping up the login screen. Okay, so let me just run that one more time. But the post doesn't. Okay. Because it's not constrained. So here, if I click get, it's actually constrained by the security. That's the reason it's actually popping up this. Okay, but if I try the post, it works right away. Okay, because I did this this is post. Again, if I try change this one to get, then it's gonna be the reverse. Okay, save it, and again, I'm gonna just close this guy and run this one. So in this case, except get, meaning the post should be constrained. So when I click this one, it will pop up the this authentication screen. Okay, uh, but if I go to get, it doesn't, because the here what we said is that get is exempted in a sense on the security constraint. Okay. All right, so we have one more topics. We actually have a couple of miscellaneous topics like a session tracking cookies and Servlet 3.0 file upload. But I'm gonna actually stop right here because we have passed 1 hour. So let me make sure.